The slope can be denoted a couple of ways. First is just a lowercase b, and I'm going to note it here as byx, and that just simply means that it is an unstandardized slope, and we can also call it an unstandardized regression coefficient. Please note that this can also be an uppercase b. Sometimes in various stat platform outputs, it will come out as an uppercase b as well. So upper or lowercase b always means unstandardized b weight. But if it is a Greek symbol beta, then that means it's a standardized version of this, which I'll get to here in a little bit. So we need the three pieces of information to calculate an unstandardized slope. And the formula is right here. We need the correlation between the two variables, that lowercase r, and then the standard deviation of x and y. And so I want you to memorize this formula, understand what's going on here, and then let's demystify this process. So take a few minutes and calculate the slope. So in our example, here are the different pieces of information, or you can run them in R if you'd like to get these numbers and just check it out and make sure that they're accurate. They may not be, like for rounding error, they may not be perfect, but I calculated the slope and it's below this slide, and I used several decimal places to make sure that it's accurate. And when we calculate the slope for this GRE GPA research question, it's about 0.0075 something. And so that's just a small slope, but that's okay. We don't expect that every 1 unit increase in GPA will cause a very large increase in our GPA. All right, so just one more thing I noted below the slide. For the unstandardized B weights, they're not reciprocal in that if we had GPA as the predictor, which doesn't make as much sense, and we had our GRE as the outcome, there would be a different B weight. But the standardized B weight, or the beta, would be the same. So you can go ahead and calculate this B weight with the X and Y are being reversed, and so you would just switch the SDX and put it up on top, and the SDY and put it on the bottom, on the denominator, and you would see that that B weight would change. So B weights in the bivariate case with just two variables, they're not interchangeable like that, but when they're standardized and it becomes a beta weight, then they are. And so you can play around with that on your own. A lot of times the best learning happens when you're just playing around with things and seeing, okay, does this B weight change? Take the R code that goes along with this question and check it out and see how it works out for you.